Alright guys, this is going to be the video for the class notes for 5.1a. The warm-up here, we're supposed to fill in the blank as to which vocabulary term applies to the definition. So the first one here, we're looking at something, it's part of a triangle that is a segment whose endpoints are at a vertex and the midpoint of the opposite side. And that midpoint right there helps us realize, okay, midpoint, there's two that we deal with a midpoint, but since we have to come out of that vertex, we're looking at our median. Our median, one endpoint is at the vertex, the other one is at the midpoint of the opposite side. The next blank is part of a triangle. This is where the altitudes are going to intersect. So we're not looking at a special segment. The special segment we're talking about is the altitude. It's where all three altitudes intersect. And we look back at the first page of notes from this chapter, we see that this is going to be your orthocenter. Then your last one is talking about a segment that joins the vertex of a triangle, so it has to come out of a vertex, and it's going to be perpendicular to the opposite side. We must remember that perpendicular forms that 90-degree angle. It's a very important vocabulary word. Okay, so we have coming out of a vertex, and it's going to form a 90-degree angle on the opposite side. We need to be very familiar by now that this is going to be your altitude. The next section with this table was discussed in the video. And then you were to draw, with these three triangles, you were supposed to be drawing we wanted you to try on your own, drawing a perpendicular bisector using M as your midpoint of segment PR. So whenever we draw we already have our midpoint, this first triangle, so we know that segment PM is congruent to segment MR. So we need to make sure we have all of our markings of a perpendicular bisector, because that's what we're looking for. Okay. Another thing here I do want to make sure we address again is that perpendicular bisector does not have to pass through the vertex. Okay, and we're going to be seeing that here. Now, whenever we draw our perpendicular bisector, we're going to focus on that midpoint, and then if I have that midpoint on this bottom side here, I'm going to take my perpendicular bisector, that segment, I'm going to want it perpendicular to segment PR. So to do that, just the best of my ability, I'm just going to draw straight up, okay, and we'll form that 90-degree angle. And then, as in the video discussed, we're going to end up seeing here that we're most likely going to have an isosceles triangle. That's whenever we see that perpendicular bisector go from the midpoint to the opposite vertex, we're going to have that isosceles triangle, but we'll discuss that more later. With this next triangle here, again, M is the midpoint, so we have two congruent segments. And we're going to take this again and draw it straight up. And this time it doesn't go to the vertex. If you want to, you can draw it beyond the triangle if you want. I'm going to end it right at that side. It doesn't matter there. And then we need to make sure we draw on our 90-degree angle. The last triangle, again, we have midpoint creating two congruent segments. And we're going to go from that midpoint straight up. And that's going to create our 90-degree angle. The next table is very important. Make sure we've seen the video for, because it explains our perpendicular bisector theorem, talking about when we have a perpendicular bisector that comes out of the vertex. It's talking about the word equidistant, talking about that we are going to end up with isosceles triangles. And even though it's not in the definitions here, we do write it in the video. And then complete problem 1 and 2. Number 3, we're going to go ahead and use that perpendicular bisector theorem. And we're going to see here that we have segment SR is going to be a perpendicular bisector. We need to understand why I know this is a perpendicular bisector, because it doesn't have it in the words. So the reason I know it's a perpendicular bisector is because I have my perpendicular marking here, the 90 degrees, and then I know that S is the midpoint bisecting the side. Perpendicular bisector. In this problem, we are going to be looking for the length of RT. Very important to remember, so when we solve for X, we don't stop and just move on. We need to make sure that we go back and use our substitution property and substitute in for segment RT. Now, with our perpendicular bisector theorem, we are told that if we have this, if we have a perpendicular bisector that comes from the vertex, the opposite vertex, where the endpoints of the base over here, or not the base, but the side over here, point Q and point T, will be equidistant from point R, from that vertex, creating that equilateral triangle. So then we have two congruent sides of the triangle. So when two segments or two sides are congruent, their measurements are equal. So what we'll do is we'll set these up equal to each other and solve for x. Please pause and solve for x on your own. We need to make sure that we're getting tutorials or help if we cannot solve for x. So these steps will be gone through very, very quickly. I'm going to go ahead and move my variable with the smaller coefficient, leaving me with 3 equals 2x minus 7. Then I need to move my constant to the other side by doing the opposite of adding. 2x will equal 10. Last step, divide both sides by 2. X will equal 5. Now we're not done because we are looking for RT. So in our picture, RT is equal to 4x minus 7. I'm going to remove x and use my substitution property and substitute in 5. And then I'll do each step here. 4 times 5 will give me 20 minus 7. Finally arriving at our answer, that RT is equal to 13. Now the rest of the page, this section of the notes was covered in the video, but one thing I do want to make sure that I was doing with my classes is down here at the bottom when we start talking about the circumcenter, the intersection of all three perpendicular bisectors. Depending on what kind of triangle, what I did with my class was I made sure that we, like we did with altitude, highlight our triangles so we can see them a little bit better. And then we understand here that in our acute triangle, your circumcenter will be inside. So I have my students draw the little points here so we can see that is inside that highlighted triangle. In our right triangle, it's going to be on the triangle just like our orthocenter with altitude, but in a specific spot. It has to be the midpoint of the hypotenuse. So right here, our circumcenter will actually be the midpoint of this side, so we have two congruent segments. And then on our obtuse triangle here, the circumcenter will be on the outside of the triangle. So we'll have to extend those perpendicular bisectors when we draw them in a minute. So now we'll take a look back at the front page, the cover page of the packet for face-to-face, the very first page, chapter 5. Everything's not filled out. We're just focusing right here where we have under Mapasico, we've got the P here for perpendicular bisector. Over here is going to be our circumcenter, so it's the second one from the bottom. Okay, second one from the bottom. We're going to have the C is going to stand for circumcenter. Make sure we're not on the incorrect one. Your circumcenter, over here in the bullet points, this is going to be the point where three perpendicular bisectors intersect. And again, the location of each is going to change based on what kind of triangle we have. So the first one we'll talk about is the acute triangle. When we have an acute triangle, as we saw on the previous page, your circumcenter will be inside the triangle. And then we will come over here and we'll look at our acute triangle, and we'll draw in our three perpendicular bisectors. I'm going to go kind of quick, so pause it and pause it so that you can get these drawn in. We're going to do the best we can because we're not using a ruler and protractor. So I'm going to take this bottom side right here. I'm just going to kind of eyeball where that midpoint might be. Make sure that I mark my sides congruent, my segments congruent. And then like what we did before, I'm just going to go from that midpoint. I'm going to go straight up, or as straight up as possible, doing it free-handed. It's not an isosceles triangle, so we're not going to go into the vertex here. Make sure that we mark that 90-degree angle. I'm marking it small because we're going to have a lot of lines going in and out here. Okay? Now I'm going to go ahead and rotate my page so I can get my next perpendicular bisector. So on this side right here, I'm just going to eyeball where that midpoint might be. Make sure that I mark that we have congruent sides, congruent segments, and I'm going to draw straight up. and then mark my 90-degree angle. Again, pause and rewind so you can get this. Then the last one, I'm going to rotate and go to my last side here and eyeball where that midpoint might be. Now, ideally, if we were measuring, when we draw this straight up, it should go straight through this intersection. So we're just going to make it go through the intersection, okay, even if we have to curve that line a little bit. And then here at that center, where all three of these intersect, right here, this is going to end up being your circumcenter for an acute triangle. When we move to the right triangle now, your right triangle, as discussed on the last page, is going to be at the midpoint of the hypotenuse. Okay, I won't abbreviate hypotenuse. The midpoint of the hypotenuse. Pause to finish writing that in because I'm going straight to the triangle now. Over here, we're going to have our right triangle. And I'm going to draw in, starting with this bottom side right here. It's going to be one of my legs. Again, eyeballing where that midpoint is, my congruent markings, and I'm going to go straight up, forming my 90-degree angle. Okay, pause and finish. Now I'm going to rotate and go to my my second leg, and you'll see why here. Whenever we find that midpoint, eyeball that midpoint, we're going to mark my congruent segments here. Now, again, ideally, if we actually measured everything out and we draw straight up, it should meet up with this other perpendicular bisector on that hypotenuse. So as you can see, mine's a little crooked, but I'm going to have to just make it meet up there. What ends up happening here is when these two meet right here, as discussed in the previous notes and in the far left column or right column over here, it ends up creating, we're going to be intersecting at a midpoint of the hypotenuse. So when the other two perpendicular bisectors from the legs meet up, that is actually going to create the midpoint. So then we automatically don't even have to measure that hypotenuse. It's automatically going to create two congruent segments. And then, even though we already have our circumcenter there, we'll go ahead and draw straight up to create that last perpendicular bisector. And then right here, I'm going to go ahead and make that a little bit bigger and color a different color. We have the circumcenter of a right triangle. And then we'll move on to our last triangle. The last triangle here being our obtuse triangle. What's going to happen with your obtuse triangle is, as discussed on the previous page, your circumcenter is going to be outside the triangle. So get that filled in, then we'll start on the last triangle, which will be right here, our obtuse triangle. I'm going to go ahead and start with this side at the bottom like we did in the other ones. It's a little bit crooked, so I'm kind of rotate so I can see it better, find that little midpoint, do the exact same thing we've been doing, and then I'm going to try to go up as straight as possible. Now, because it's going to be outside, I'm going to have to extend this perpendicular bisector to exit outside of the triangle. What I'm going to do now is I'm going to go ahead and go to this side next, okay? And eyeball that midpoint, same thing, congruent segments, and then I'm going to go straight up the best I can, making sure that even if I have to adjust my line, the intersection of these two has to be outside. It cannot be on this side. It's got to be outside of the entire triangle. So even if you have to adjust it, make sure it's clearly outside of that triangle. Then whenever I go to the last side here, this one will really have to kind of adjust. We'll just eyeball where that midpoint would be. And then even though I go straight up to form the 90-degree angle to intersect with the other two, I'm also going to have to go downward. And I kind of had to shift a little bit to make sure that it intersects with the other two perpendicular bisectors. And then here we have our circumcenter for our obtuse triangle. Now the last two bullet points are going to deal with the circumcenter theorem and the circle that is that we can create with our triangle. This circumcenter is also going to be this, the center of a circle that is circumscribed, discussed in the notes, circumscribed around the triangle. So if I If I draw a triangle around, or sorry, circle all the way around these triangles, making sure that the circle touches each vertex, that circumcenter is going to be the center of the circle. Okay? Then the theorem, the circumcenter theorem, tells us that once we have that circle drawn out, and we have that triangle, I'll kind of draw a triangle over here, and I apologize, my circle's probably not going to be very good. I'm not going to draw all three perpendicular bisectors. I'm just going to pretend that I did, and that's going to be at the circumcenter where they all intersect. When I draw the circle, the circumcenter theorem states that when I draw a circle all the way around, the best circle I can, where all three vertices hit that circle, the circumcenter theorem is telling me that the distance from that circumcenter to each one of these vertices right here is going to be the same. So each one of the vertices is equidistant from that center, or the circumcenter, that point, is what we call equidistant from the vertices. And make sure that you've watched the other video, hopefully you did before this one, so that this makes a little bit more sense. And that's what we covered in class.